Hello everyone. So previously we had successfully designed a restaurant order management, right? So today what we'll be doing, we are asked to design a distributed log manager, right? Yep. So we are asked to design this one distributed log manager, right? So let's see what the question states here. Complete question. So design a distributed log manager, nothing but DLM, that allows multiple clients to safely acquire, right? That allows multiple clients to safely acquire and release logs, acquire and release logs on shared resources, so this point is very important, basically these two words, right? Acquire and release logs on shared resources. Ensure that only one client can hold a lock at a time, right? We have to make sure that only one client can hold a lock at a time, and locks automatically this one expire after a timeout if not released, right? So we have to simulate concurrency using the threads in Python. We have to simulate the concurrency using the threads in Python. Yeah. So this is fine. Now let's do one thing. We know the question. Now what shall we do? Let's collect the functional as well as the non-functional requirements. Then we can move on with the further things. First, let's collect the functional as well as the non-functional requirements. So here first, let's go with the functional requirements. The first one is acquire and release distributed logs. Yeah, we should be able to acquire and release the distributed logs. The second one here, only one client holds a log at a time. So this is strictly mentioned in the question as well. Yep. So the third one, logs expire automatically after timeout. Logs expire automatically after timeout. And the fourth one, finally, this one, clients retry if resource is already locked. Clients retry if resources already locked. Yeah, client should be able to retry if resources already locked. That's what. Yeah, so this is fine. Let's move on with the non-functional requirements here. The first one, thread safe operations. Yeah, thread safe operations, this is one of the thing. Second one, in memory low latency design. Yeah, this one also we have to keep in mind. The third one, fault tolerant cleanup of expired locks. Yeah, fault tolerant cleanup of expired locks. The fourth one, scalable design for future distributed system. Yep, scalable design for the future distributed system. So this is fine, man. So let's move on with the further things. Algorithm choice. Yeah. So this is the main thing. So what is the algorithm that we'll be going with basically, right? So we will be making use of a centralized table along with a timeout expiration. So basically, we will be going with a centralized table plus timeout expiration, right? The reason is it's simple, it's thread safe and easy to extend to the distributed setup. That is the reason we'll be going with a centralized table along with the timeout expiration. Yep, so this is fine. Next, let's go with the concurrency and the data model. Yeah, so data model. So this will be going with log table equals. So one thing we'll be going with the resource ID. With the resource ID that consists of the owner ID as well as the timestamp. Yep. So the concurrency here. So we will be making use of threading.log just to ensure atomic lock operations. Yeah, we'll be going with the threading.log. So just remember this one. Yeah. So so also we'll be going with the background thread that cleans up expired locks. That cleans up expired locks. Right. So this is about the concurrency as well as the data model. Important one. Yep. So the next part, let's move on with the UML diagram, actually the main thing. Accordingly with what we have discussed till now, let's move on with the this one UML diagram, right? So first thing, we'll be going with the three classes here. See, under the main class, this one is distributed lock manager, right? So this one, client A as well as the client B, two clients are directly related to the distributed lock manager class, right? So this is the main class or the base class. So this is the main class or the base class. Yep. So first we are going with these are some of the parameters: lock table and the global lock, which is of the type dict, which needs this one, which is of the type dict, and this one lock, actually global lock. So these two parameters, and we will be going with the three methods: acquire lock, release lock, as well as the cleanup expired locks, right? So these three methods we'll be making use of within this particular class, distributed lock manager. So here sorry, we will be going with the two client classes, one so within the client A and client B, so we will be going with acquire lock as well as the release lock. Same thing, acquire lock and release lock, basically. under the client A and client B. So client A and client B are directly related to the distributed log manager class, right? So this is fine, I believe. So whatever we discussed, the same thing, accordingly with that, we have designed the UML diagram. Now the UML diagram is complete, and we have discussed the this one algorithm choice as well. We went with the algorithm choice. Yep. So we discussed the this one, what do we call? Um, this thing concurrency as well as the data model, that also we have discussed. So now we have designed a UML diagram as well. We have designed an UML diagram as well. It's front of you. Now what shall we do? Based on that, based on this itself, let's start writing the code. Yep, let's start writing the code. So first thing here, as per the UML diagram, let's go with a distributed log manager class, right? So I'll just go with, let's define the class distributed log manager, right? So this is fine. Now within the distributed log manager class, first thing, let's go with the initialization part, right? So I'll just go with init here, nothing but the constructor part. So along with the self, I need one thing, nothing but the timeout. Timeout, initially I'll set this one to the 5. Yeah, this is fine, man. Yep. Next, log table keeps the track of which resource is logged by which client and since when, right? So we need log table. Let's initialize the log table. So this one I'll just go with here, log table, or yep, let's go with the log table. Let's make use of the dictionary here. This is fine. Next, let's go with a global log that ensures thread safe, right? That updates to the log table. Yeah, I'll just go with a global log here. Global log. Let me go with a, let me initialize this one to the threading.log actually. This has to show. So we haven't imported. Oh, I forgot importing this one. Yeah, I'll just give here threading.log here first. Let me do one thing. Let's import threading here. Yeah, going with the thread set this one, right? I'll just import the threading as well as the time, right? So this is fine, I believe. So now the error is gone. Next, let's do one thing. Let's go with a timeout. Basically, timeout defines how long a log remains valid. Yeah, we know this. So I'll just go with timeout here. Let me initialize this one to timeout. Yep, so this is fine. The final one here is, let's start the background thread for cleaning expired logs, right? So I'll just go with here threading dot thread. Yep. So what I need to do here, let me set the target to mm, clean up. So this has to show, nah, not this one actually. Actually, this had to show clean up expired logs. This is not. Let me type clean up expired logs. Yep. So this is fine, and set the daemon to true initially, right? So daemon to true actually, right? So let me set this one to true. So this is fine. And finally, let's start the thread. I'll just go with a start here. So this is fine. So we have successfully completed distributed class manager class. Sorry, this one initialization part within the distributed log manager class. Next, we have to acquire the log, right? So for that one, let's go with the acquire log function or the method. So I'll just go with def acquire log. Yeah, acquire log of, let me go with here, along with the self, I need certain things. One is resource, another one is client ID. These two things I want. Yep. So within this method, we have to ensure only one thread can modify the log table at a time. So this one was one of the requirement, right? If you remember, right? So I'll just go with global log. This has to show no. Okay. Let me write this one entirely then if it is not showing. Yep. Let me type this one. Yep. So what was the first case? So what will be the first case? If you remember, so resource should not be locked initially, right? And also we have to, if the resources are not yet locked initially, then we have to grant the lock immediately, right? So then we have to grant the lock immediately. So for that one, I'll just write it in this way. If resource mm, not in, sorry, let me leave the space here. Yep. If resource not in, where lock table, then if resource not in lock table, then I'll just go with lock table. Let me copy this one. Yep, let me paste it over here. Lock table of resource. Let me pass the resource here, and I'll just go with client ID as well as time actually. Time dot time. Yep, so this is fine. Your parenthesis as well. Yeah, let's print something for the interactive purpose man here. So I'll just go with F. Let me we'll be making use of the string interpolation, right? So I'll just go with your client ID. So this is fine. Acquired log on. So let me pass the resource as well. Yep, again within the square braces. This is fine, man. Yeah, the next step, let's return true. Let's return true. So I'll just go with, yep, return true, right? So this is fine. So yeah, we are done with this method, right? So we are done with this method. So one thing, so I have done this one wrong, man. Sorry, 1 second. So let me move this one actually. Mm, this is fine, I believe. Now this works actually. This is fine. Yep. So next, what shall we do? 1 second. Yeah, we are done with this part actually. Resources. So this is fine. Next, if what if the resource is already locked actually? Then what we need to do? So I'll just go with the else here. So I got this one disturbed with this one indentation actually here. So let me do one thing. I'll just go with the owner here along with the owner T. Let me assign this one to the lock table actually. Yep, lock table of, let me pass the resource, right? When the resource is already locked. If lock has expired, if lock has expired or if lock got expired, then we have to grant the lock to new client, right? So let's go with a simple if condition here. If here, if time hyphen t, if it is greater than timeout, uh, this is fine. Then let me print something for the interactive purpose. I'll just go with F. So this is fine. Mm, client ID, this is fine. Took expired log on. I'll just pass the resource, right? Let me pass the resource, right? So this is fine. Next, let me go with log table here, log table of resource. Let me pass the resource. Let me assign this one to the client ID. It has to show. Yep. So this is fine. And along with the time. This is fine. Next, we have to return true, right? So I'll just return here in this case true. Yep. So otherwise, we have to what we have to do. Otherwise, resource is still locked. Client must wait for some time, right? So I'll do one thing. Let me come here. Yeah. I'll just write else here. So else, I'll just print something for the interactiveness. We're making use of the string interpolation here. Client ID. This has to show actually. Yeah, client ID. Yep. I'll just go with waiting. Yep. So this is fine. This is enough actually. Let me pass the resource. Yep. Locked by. Let me pass the owner here. Yep. So this is also fine. Simple. Let me return false. Yeah. Let me return false here. Yep. So this is it for the acquire lock helper method. Yeah. Or the method. Right. So this is fine. Next, let's move on with the release lock function as discussed in the UML diagram. Right. So we should be able to release the lock. Right. So for that one, let's go with the helper method. Just give me a second here. I'm getting the call. So yeah, let's continue. So let me go with the here release lock method. So along with the self, I need certain things. One is resource and another one is client ID actually. Yep. So this is fine. So within the release lock method, first thing we have to lock the global access, right? So before modifying the lock table, so I'll just go with initially see with global lock actually. So this has to show, yeah, with global lock. So within this, let me write the simple if condition because see here, listen to this carefully. We have to release the lock only if the same client holds it, right? So we have to release the lock only if the same client holds it. So how can I write it in the form of code? If resource, if resource in this one lock table, yep. So this is fine. And again, lock table of, let me pass the resource here. Yep. So this resource along with the 0. If the value is equivalent to the client ID, this one, then what we need to do, we have to delete, right? I'll just make use of the del here. I'll just go with what we need to delete the lock table that containing the resources, right? I'll just go with the lock table here. This has to show, yep. I'll just go with resource. Let me pass the resource, right? Let's print something for the interactiveness here. So I'll just go with, let's go with the string interpolation here. So I'll just go with the client ID here. So this is fine. Relist. So this is fine. Log on. Let me pass the resource. Let me pass the resource. Yeah. So this is fine, man. Next, what shall we do? Let's go with a method. This one, clean up expired logs, right? So we should be able to clean up the expired logs, right? So this will be carried on within the background thread, right? Clean up expired logs actually. Yep. So this will be carried on within the background thread. Just remember this. So I'll just go with def clean up. Let me give here expired logs, right? So let me pass self here. So within this method, first I'll just go with while true. So yep. So let me go with this one with global log. Yep. So this is fine. So within this, let me set the now to this one dot time. Yep. So this is also fine. Now we have to find the expired logs older than the timeout. Yeah, that also we have to do. So let me name the variable here expired. This will be relevant actually here. Yep. So R for R. So I'll just go with O comma T. So this is fine. Comma T. And I'll just go with a lock table here. Let me go with a lock table dot items. Let me go with the items. Yep. So this is fine. If now hyphen T, if it is greater than timeout actually. Let me go with a timeout. Yep. So this is fine. Next step, what we need to do here, we have to remove the expired entry. So let's go with a simple for loop here for R in this one. Let me give expired. This is fine. So within the for loop, let's do one thing. Let me go with a simple here just for the interactiveness here. So I'll just go with lock on R. So this is fine. Expired and this one. What do we call? Removed actually. Expired and removed. So this is fine. Let me go with del. What we need to delete? Lock table of resource R, right? So I'll just go with the R. Yeah, right. This is fine. Now let's do one thing. Let me go with the sleep here and let me set this one to the 1, right? So we are just running every second. So that is the reason I have passed 1 here by by making use of time dot sleep here. So this is fine. So we are done with the cleanup expired logs method as well, right? As well. Now let's go with the client simulation. We have to, or Yeah, let's go with the client simulation. Nothing but here, threads represent different clients, right? Just remember this one, threads represent different clients. So I'll just go with the def. Oh, I have to go out of this one, right? So this is fine. Def, let me go with here client task. Within the client task, so I'll just go with DLM as well as CLD. Let me go with the CID. This one, let me go with the resource actually. Resource, yeah. So within this method actually, let me go with a for loop here and range actually um 3. Let's set this one to the 3. This is fine. Within the for loop, first we have to attempt to acquire the lock, right? I'll just pass here DLM dot, let me call the acquire lock method here. Yeah, not showing. Okay. Let me go with the acquire lock. Let me copy this one and let me paste this one. I don't want to type this one, man. Acquire lock of, let me pass the resource as well as the this one CID. Yep. So this is fine, man. Yeah. So within the if condition, we have to hold lock for the 2 seconds just to make sure that the simulate work actually, right? I'll just go with time dot sleep here. So let me pass 2 here. This is fine. The next thing here, then we have to release the lock, right? I'll just go with DLM dot release lock. So this one will be release lock actually, release lock of mm, resource, resource as well as the CID, as well as the CID, right? Else what we need to do, I'll just pass the else, sorry, else, this is fine. Else, if not acquired, then we have to wait and retry. So I'll just go with the time dot sleep here, time dot sleep. Let me pass 1 here, right? So let me pass 1 here. So this is it for the this one client task method, right? So we went with the client simulation. Basically, threads represent different clients. We know this. Yep. So this is fine. Now, let's go with the main execution. Nothing but let's launch multiple client threads, right? So this is for the example usage. So let me get the example usage or the demo usage from the Google as usual. Just give me a second here. So just give me a second here. Let me paste this one over here from the 57 to 66. Let me explain this one clearly. So DLM equals distributed. We have called the distributed lock manager this one class here. We are just creating a lock manager with 4 seconds timeout. Timeout we have set this one to the 4, right? So we are creating a lock manager with 4 seconds timeout. Then what we are doing here. So threads equals this one, whatever I have given here. We are just creating client threads that are competing for same resources, that are competing for same resource actually. The final one here, this one, so we have to wait for all the clients to finish the for loop one. So here 65 and 66, right? So we have to wait for all the clients to finish. Yep. So we are done with this part. We are done with this part. I mean, we are done with the coding part itself, right? So we have discussed this one step by step. I think no need to discuss this one again, right? So I think no need to discuss this one again. So what is the output that we need to get here, right? So what is the output that we need to get here? Let's discuss the output part and then we can run the code. Yeah. So just give me a second here. Mm, yeah. So before that, let me. Yeah. See here. First one, we are just going with this one clean up client task actually. Then we are going with this one, right? So the output first here we need to get here is client one acquired, log one on this one RESA, right? So that's what we have given. So this is fine. Client two waiting result A locked by client one, right? So again, client one release lock on reset A, right? Reset A, not the result, sorry, reset A, right? So client 2 acquired lock on reset A, right? So client 3 waiting reset A lock by the client 2. Finally, lock on reset A expired and removed, right? So client 3 took expired lock on result, this one reset A, and then finally client 3 released lock on reset A. So this is the output that we need to get here accordingly with what we have written, right? The print statements, and you can just check actually based on the code that we have written actually, right? So this is fine. So here what we are doing, so we are calling the distributed manager here, right? So this one lock manager, so this class actually. It manages all the active logs with a timeout. So timeout, we have set this one to 4. Each client thread tries to acquire a lock, holds it for 2 seconds, then releases it, right? So this way now, if another client tries to acquire while locked, it must wait or retry, right? It must wait or retry. A background thread removes expired locks automatically, right? So if let me run the code and let me explain the output, you'll understand this one even clear for this particular this one code actually. I'll just go with Python followed by the file name dot py, right? So type object does not support the content manager protocol. Line number 17, acquire lock. Where is it? Oh, I have, so I should give equals here actually. Line number 17, 17. So this is correct itself, right? So why am I getting the error here? Acquire lock. Self dot global lock. So this is fine itself. What's wrong here? 1 second. Acquire lock. Hmm. Type does not support the content context manager protocol. Just give me a second here. So mostly I have initialization part I would have done wrong actually. So this is with self dot global lock. So this is correct itself. Global lock here. Lock table is fine. Self global. Yeah, see here. I have not given parenthesis here. So this is fine. Now let me give clear screen. Let me enlarge this one. Yep. So let me give here Python followed by the, sorry, what did I give, man? Oh, what is happening here? Clear screen here. So let's do one thing. Let me delete this one. Sorry. Let me copy this one entirely. Python followed by file name dot py. So let me hit enter. So yeah, see here, acquired lock on reset A. So this is fine. Client 2 waiting actually. Client 2 is waiting. So this is correct. Client 2 is waiting actually. Yep. And we are going with the client 3 waiting reset A locked by client 1. Client 3 waiting reset A locked by client 1. And client 2 waiting reset A locked by this one client 1. So this is correct. Next, client 1 release clock on reset A, right? So this is correct. Client 1 release lock on this one. Then again, client 2 required lock on this one, acquired lock on this one, reset A. So then again, waiting, released, acquired, released. Yeah, we are getting the desired output, right? So we are getting the desired output as per the question. Yep. So we are done with the coding part and we have discussed the output part as well. Right. So now, as we are completely familiar with this one, as we have completed the coding part and as we have discussed the this one, what do we call output part as well, let's go with the limitations of the current code. Let's discuss the limitations of the current code. So these are some of the limitations actually. What is the first limitation here? Not truly distributed, right? So not truly distributed in the sense it is not centralized, right? For the distributed, this one, right? So we are just going with a centralized in-memory model here, right? So this is just for the CLI demo. So, the second one is no retry queue or fairness mechanism here. So first come is not guaranteed here, right? So this is one of the thing. And the third one is no persistence here, right? Locks vanish on crash actually. So we are not going with this one database, external database here. We are just going with a in-memory model, right? So basically we are just solving the problem here. We can just discuss about the external database that we can use, that we can do, rather than we are just going with a single file CLI demo based code, right? So this is fine. Next, we are done with this part. Next, finally, let's do one thing. Let's move on with the last one, nothing but alternative algorithms and the trade-offs, right? So the first thing, we can make use of the Redis based lock, right? So we call this one as red lock actually, red lock, right? So here, the main pro of making use of the Redis based lock is, so it's really distributed or real distributed and scalable. And also the main disadvantage of using it is network dependency. Network, we need the network dependency and the setup is required. This one. The second one, Zookeeper log service. When I say Zookeeper log service, strong consistency and reliable, high latency as well as the complex setup. So this is one of the disadvantage. Advantages, strong consistency and it is reliable. Disadvantages, high latency as well as the setup will be complex, right? So third one, we can just go with a raft based consensus log, right? So what is this? So basically it is fault tolerant actually. Yeah. Leader election, it goes on with this one leader election basically. And the main con is heavy implementation overhead, overhead actually, heavy implementation overhead. Yeah. So what we have made use of, actually the implementation that I have made use of, so that is completely centralized actually. Accordingly with me, that is completely centralized. It is simple, fast and mainly educational, right? So here, but the main con is single point of failure. We are just solving the problem and going for the CLI demo. So I just went with this. Yeah, this is simple and uh, better one actually. Simple and fast to be frank. Yep. So we have successfully designed the distributed lock manager, right? So next, what we'll be doing, we will be designing the this one in memory cache, right? So we'll be designing in memory cache, right? So I hope whatever we discussed along with the coding part is completely clear, right? So for now, this is it. Thanks for watching, guys.